When Fukushima was blowing up, we ordered Geiger counters, and once we got them, then we were able to measure what was around us, but we couldn't. There was no way to publish that. So the Geiger counters were only good for us. And so in order to have a bigger impact, then we designed an interface for the Geiger counters to start publishing data onto the internet. We're planning to teach people both here and up in Fukushima how to design their own Geiger counter, or how to build their own Geiger counters, and then upload that data onto the internet for their local communities. Specters, as Colin was mentioning, so normal Geiger counters, like the dosimeters that for the microsieverts readings that the government is giving you, are using shielded tubes that are only sensitive to gamma. But these ones that use the 2-inch pancake Geiger molar tubes, these are called 2-inch pancake tubes because they have such a huge surface area. And these are very good for measuring contamination, surface contamination for alpha, beta, and gamma. So when Safecast first started, we had like 5 Geiger counters shared amongst all of us. And we were like, all right, what are we gonna do with these 5 Geiger counters? And so like Peter and Ray Ozzie, you know, the geniuses that they were, they said, all right, we're gonna put them in a car and drive around all over Fukushima and like measure. Because that was actually really great, because then it was able to take measurements all over the place. And you can see right now the government is trying to do more measurements, like measuring 1,000 spots, but they're really, they're like kind of walking and then writing it down, walking and writing it down. But I think this kind of thing really needs to be automated. And so this design was, it would take data from the Geiger counter, and then it has a GPS module. So the GPS module would provide location and timestamp, and then it would automatically write to an SD card. And so so it would take approximately 5,000 to 10,000 data points from a drive, from like maybe a 3-4 hour drive. And then after that, then you just kind of take the SD card, upload it onto the internet, and then you have like a full map of like all the levels everywhere you drove.
This one mounts on the window of a car. We put the web straps through the glass and then roll the window up on it. It has a suction cup on the back to kind of stabilize it against the glass. We lead the USB wire in through the weather stripping on the door and close it. Then connect it to the PC. The PC then sees the devices in the box, which is a GPS receiver, a memory, a thumb drive, a memory stick, and then the Arduino Geiger counter controller. Okay, it establishes communication with those, gives a display, and then when we click start, it starts recording the correspondence of the coincidence of the GPS location, the time, and the current reading of the 1-minute average reading of the Geiger counter. Okay, so then you just forget about the box mostly and just drive where you're going, or hopefully somewhere deliberately interesting where we haven't collected data before, and the system collects data by itself.
So this is Minami Soma, this is Itatemura, this is the 20-kilometer boundary here, and this is Fukushima City. So here we're seeing a half microsievert per hour. Now we're going to drive a couple of kilometers around here. Let's go up to 0.9. Now we're going to drive maybe 10 kilometers or 50 kilometers around here, Itatemura. We'll see about 4 microsieverts in the air. We're going to go into Minami Soma. Just click on the ocean side, please. It goes down to 0.4. And from here we're going to drive a couple of kilometers into the mountains, and we find about 10 microsieverts. So what is happening here is the phenomena that we're seeing wherever we measure, is that there is a huge variation in radiation when you start measuring it. The reason for that is that when the plants exploded, each explosion basically threw up contamination into the air, and that got distributed. Though I personally don't understand exactly how and where what went, we can measure that, and that's what we're trying to do. We're just trying to measure where it went. So we can see there's about 0.6 microsieverts on the platform. And this is the city that we're going to cross the river, and we're going to go to the other side of the river in the city, and we just click on this red dot here. And here the system measures about double the radiation. So what we're seeing is within the city there are quite big variations in radiation. So what we feel is important is that unless we measure at this level, you really can't pin down what the radiation levels are that people are exposed to. The area is about, I think, correct me if I'm wrong, 120 kilometers, right around that, away from the plant. So it's much further away, but you're actually finding here higher levels of radiation in the air. And the reason for that is that there's some reason that the aerodynamics have deposited more contaminated material here than is being deposited in Iwaki, for example. It is very difficult to really predict where what has gone. If you think about this, now we're talking about an area of about 200-300 kilometers, and unless you go and start checking it, you really can't easily predict where you will find what. So what is very important to understand is when we measure at 1 meter, we're actually not measuring what is in the air. We're measuring the amount of radiation that comes from the ground up because of the contamination that happened. This is very important to understand. Lots of people think that radiation is coming from above. Initially it did, but once it has hit the floor, it just basically chemically bonds with whatever it touches. We have been measuring at a house in Koriyama. So here at this house, the owner of the house, she had a garden, and this was a new house, she had not put anything in it. But what she had done is she had divided the garden in 2 areas. One area where she had removed about 2-3 centimeters of soil, and then there was another area where she had left everything as is. So this is how it measures before the soil is removed. So we're seeing maybe about 5.6 microsieverts, and then if we go to the next picture, you see that the removal has reduced the radiation by 0 to 0.93, about 80%. If you would go to the second floor, you will measure about double. And the reason for that is that the contamination on the roof basically radiates inside the house. The contaminated material can accumulate in spots, typically drain pipes or somehow where the water has flown, and it leaves a highly contaminated deposit area. So if you're around the house, you have to actually go and look for where you have these so-called very localized hotspots. And then if once you know about it, you could technically go do something about it or avoid touching that area. And we hope over the coming month and a half or 2 months to give away all these Geiger counters, and we are trying to select different areas and different groups that can maximize the use of these devices.
I think if people were monitoring around Fukushima, then it would have at least kind of kept everyone honest, or at least keep people on good behavior. So we're not like anti-nuke or pro-nuke, but I think, for me personally, I am pro-data. I am pro-monitoring.
But I think the technology that will come out of this exercise will allow other locations to much easier to be scanned than has ever been possible. There's no system that actually does mobile scanning in an affordable way. So this will allow us to give other communities the same tools. Basically all of the design we have is open, anybody can copy it and is welcome to do that.
In a few more years, we might understand it, but we're only going to do it if we have lots of data and lots of people looking at the statistics. And we want to put the information into those equations so the people who know how to work them can get information that's meaningful.